In today's video, we're going to discuss how to write function rules. We have a couple of different methods for you to consider. Method 1, and this works well when your x values are in order. So if your x values are counting 1, 2, 3, 4, 5, there's no number skipped. This method works well for that. All right, so step 1 is to determine the common difference in the y values, or the output values. Okay? So how do I get from 4 to 7, 7 to 10, 10 to 13, 13 to 16? So what is my pattern? Well, I'm going to add 3 each time. So my common difference is going to be 3. This is a number that will be the coefficient of x. This is a number that we multiply by x. So we have a partial equation. Our partial rule will be y equals 3x, and then there may or may not be something else to go with it. So we will have to figure out what goes in that box there. So that is our partial rule. So our partial rule is y equals 3x, and then it might be plus or minus something, we don't know. All right, step 2, determine if anything needs to be added or subtracted to make the outputs correct. So, for example, if I need to go from 1 to 4, and I'm looking at how do I get from 1 to 4, well, I added 3 here. 2 plus 3 doesn't give me 7. I would multiply by 3 here. 3 times 1 gives me 3, but not 4. 3 times 2 gives me 6, but not 7. 3 times 3 gives me 9, but I need 10. 3 times 4 gives me 12, but I need 13. 3 times 5 gives me 15, but I need 16. So I would have to add an additional 1. So my final rule would be y equals 3x plus 1, and that's what would go in that space here. Okay? So this common difference becomes your coefficient, and then you have to do a little bit of testing to see if anything else needs to be added or subtracted. So I'm going to check my work just to make sure. So if I have 1, I'm going to have 3 times 1 plus 1. 3 times 1 is 3, plus 1 is 4. And if I compare my two charts, 4 and 4, they match. So 3 times 2 plus 1, 3 times 2 is 6, plus 1 is 7. That also matches. 3 times 3 plus 1, 3 times 3 is 9, plus 1 is 10. That also matches. 3 times 4 plus 1, 3 times 4 is 12, plus 1 is 13, which also matches. And 3 times 5 plus 1. 3 times 5 is 15, plus 1 is 16, which also matches our chart. So our final rule, y equals 3x plus 1. You may also see this written, f of x is equal to 3x plus 1. It's just a different notation. F of x and y are interchangeable. They mean the same thing. So either one of those would be the correct answer. All right? Method 2. This works well if your x values are not in order. So if you skip numbers or they're just not consecutive, this works pretty well. So number 1, look at the first input-output pair and ask the question, what could I do to x to get to y? Okay, so what could I do to 2 to get to 12? And I like to make a list of my options. So what I might be able to do is I might be able to multiply by 6. 2 times 6 is 12. 4 times 6 is 24. 6 times 6 is 36. 6 times 8 is 48. So that actually worked. Okay? So since it worked, my function rule is going to be y equals x times 6, or 6x. All right, example number 2. Same theory, my values here are not in order. So what could I do to get from x to y? Well, the first thing I could do is I could add 2. Negative 1 plus 2 gives me 1. 1 plus 2 gives me 3, but I need 5, so that's not going to work. Okay, I could also multiply by negative 1. Negative 1 times negative 1 gives me 1. 1 times negative 1 gives me negative 1, which is not 5. So that didn't work. So it's looking like I'm going to need to do 2 steps here. Okay, so what about if I multiplied by 2 and then added 3? So let's test that one. We multiply by 2 and add 3. And it's a good idea to keep a list of everything you try so you don't start trying the same thing over and over and over again. All right, so if I multiply negative 2 times 1, that gives me negative 2, plus 3 is 1. 1 times 2 is 2, plus 3 is 5. 0 times 2 is 0, plus 3 is 3. 5 times 2 is 10, plus 3 is 13, so it looks like that's going to work. So our rule would be multiply by 2, so 2 times x, and then adding 3 plus 3. And then we're going to go back and check our work before we assume that that's correct. So we're going to have 2 times negative 1 plus 3. 2 times negative 1 is negative 2, plus 3 is 1. That worked. 2 times 1 plus 3. 2 times 1 is 2, plus 3 is 5. That worked. 2 times 0 plus 3. 2 times 0 is 0, plus 3 is 3. That worked. And 2 times 5 plus 3. 2 times 5 is 10, plus 3 is 13, and that also worked. So my final function rule, y equals 2x plus 3, and again, you might also see that written f of x equals 2x plus 3. Different notation, same meaning.